Okay, good afternoon, everyone. This is Ganesh Kumar Natarajan, Director in Cloud Architecture and Design team from AT&T.
And I'm Ronnie Haddad. I'm a Cloud Solutions Architect at Ericsson.
Hi, I'm Sharat Rao, and I'm a Cloud Solution Architect at Ericsson.
All right. So security is an important topic in cloud business. I mean, especially if you are large-scale telco cloud providers, you need to take care of hundreds of deployment day in and day out. If we speak about security, two things comes into our mind. One is who accesses the cloud, which is typically the authentication part. And the second part is what level of access or privileges that we can provide to these users. That's the authorization part. So the topic for today is all about how we can govern access to the cloud, how we can define these policies, and consistently distribute across multiple different types of clouds on a more dynamic and on-demand basis. So without further ado, let's go to the packed agenda. We'd like to talk about a little bit of primer about RBAC and OpenStack. What is it, and what are the different constructs defined in OpenStack. And I want to talk about some of the problems in the telco world. One is, the plethora of users or roles. It's multiple groups involved in deploying all the cloud data centers. We're going to see the different types of groups. And the second part is the evolution of cloud itself. Talking about edge deployment, IoT. We would soon move away from a double-digit to kind of a triple-digit cloud deployments. And so how do we manage all these different issues? That's where we're going to talk about the different RBAC strategies. And then my team is going to talk over a simple use case, an end-to-end use case, how to leverage that. We also made it a point that any presentation we give, we wanted to give a demo. So we put some effort to show you the demo, how these techniques would really work. And we also wanted to compare some of the community projects that's already in the, in the open community. We will compare that. And finally, we will call out to community how we could collaborate and improve more in this space. So when you talk about cloud data center, especially OpenStack data center, what do we really get is a bunch of resources that are exposed to the user, right? You want to come and create a virtual machine. You want to come and create a network. There is a Neutron service, storage, there is a Cinder service. All these core services provides API for the users. Now the question is, how do we govern access to all these APIs across multiple users? That's where the RBAC framework comes into picture. RBAC stands for Role-Based Access Control. It's a policy that is defined today as part of the Keystone project. In order to understand RBAC, you need to understand a little bit of terminologies. Let me quickly go over that. The first one is the role. Role defines typically an action, or you could say that it's a personality that is assigned to a user to determine what type of an action he can perform. That is basically about the job functions typically the user has in the organization. I mean, if you install DevStack, normally you get two default roles, right? Like an admin or a user, but that is not sufficient in the real telco world. Second is the user. User could be a human, or it could be a software who wants to use the cloud. And the groups is a collection of users and roles. In fact, you would be surprised to see how we actually leverage group to solve some of the RBAC strategies that we're going to talk over in the coming slides. And then you got projects, which is a user account or a tenant. You got domains, which is nothing but a containers for putting everything together to avoid some name collisions in the organizations. And the next is rules. So this is where you actually map a role to an API or an action. In fact, you would define multiple rules in a file. That file is called policy.json. So every core OpenStack services has its own policy.json as shown in this picture. So one thing you need to understand here is Keystone helps you to define the policies, but the enforcement actually happens at the respective core OpenStack services itself. What we really wanted to have is API-driven policy management. In fact, a couple of projects in OpenStack made an attempt. Keystone made an attempt to do it via API, but I think unfortunately they deprecated since Mitaka. And then even there is Neutron that exposes certain APIs, but it's not really a full-fledged capabilities here. So now that we understood a little bit about RBAC, let's go and understand the problems. The first problem is, like I said, growing number of user groups within a cloud data centers. Typically there is this capacity planning group who would come and do the rack and stack, and then they would set up the host aggregates. Once they are done, they will call the DevOps team to go and install all the software on it, I mean the cloud software. Once that team is done, we would call upon the cloud operations who would come and deploy all the VNFs. And then there is this network operations team who are specifically interested in managing all the fabrics, your leaf, spine, AGGs, D2IB, gateway, and so forth. I mean, you get the picture, right? So there are tenant users, there's a CS4 security we all know, and we deal with it. And then there's a tier 3, tier 4 operations, and so on. So the default roles, why I'm trying to say here is the default roles that are coming out of OpenStack is not sufficient to address these large user groups. So that is something that we all need to think about, how to manage all these roles and assign to these users. The second problem is the cloud evolution itself, right? So I wanted to share, how we, at least in AT&T, have evolved over the time. I mean, like everybody else, we started like with the centralized keystone. As long as the data centers were few in numbers, we were fine. But we know what was the problem, right? I mean, all the OpenStack Summit would come and talk about what are the issues in Keystone, centralized Keystone, how do we know what is the token issue, moving from UID to Fernet, and Memcached, so many things. I mean, they all made a talk out of that. So we all understood the problem, and then we evolved, like probably I would say like 2 to 3 years back, we moved to a solution where we made all the OpenStack data centers independent of each other. We made it modular so that when the keystone fails, it just fails in that particular region. Whereas in the first case, if it fails, it's going to impact all the regions. Now, starting last year and more towards this year, AT&T has moved to this, what is called the next-gen cloud. Actually, in fact, we named our cloud as Network Cloud. And you would have pretty sure learned more about the Airship project and Akraino project that are all outsourced out of AT&T. So with all those technologies, we actually containerized our control plane. So we kind of put a Kubernetes, then we run OpenStack services on top of that. What it really helped is our deployment became lightweight, it faster, but that comes the problem, right? Now you are talking about not in 2-digit data centers anymore, and it's soon, with the edge and IoT, it's going to be thousands of data centers. Now, how do we manage that? I mean, if you take, for example, Joe as an operation user, he has access in New York, he has some certain privileges. The same user, when he goes to California, he should also have the same access. So how do we consistently define the policies and distribute across these different data centers? That's the challenge I think we wanted to solve. We think that we have solved, but we need the community help to move forward. And the third problem is the security loophole itself, right? For example, you give an admin privilege for the user to go and create a NOAA aggregate, for example. You would go and do it happily. But the same user can come and delete the NOAA aggregate. Or in fact, he can delete a completely unrelated entity like a neutron network. You cannot stop it. So that's the real security loop. The question is how we can apply the principle of least privilege, right? So that's the third problem that I think we need to solve. I also wanted to take a minute to talk about the multiple layers that typically you see in the data centers, right? It's just not the OpenStack cluster, if you really see. If you need a storage, you're going to put a Ceph cluster. And you wanted to run containers, you would put a Kubernetes cluster. On top of that, you would have the OpenStack cluster. And many a time, we don't even talk about fabric. That's the very key thing. The leaf and spine and the ag leaves, that everything connects to your data center. There is some ACLs that also needs to get applied over the fabric. And once above that, you have the other orchestration layer like ONAP. ONAP stands for Open Network Automation Platform. That helps you to bring down the, spin up the VNFs on top of your cloud. So RBAC itself is actually applicable to all these different layers, if you really see, right? But for today, this session, our focus is only about handling the OpenStack cluster. Maybe we'll all come another day. Maybe we would present something like a unified RBAC solution that would protect your cloud stack end to end. All right, so this is the interesting part. So how do we actually solve the problem? So we actually are showing 3 different strategies. One is manual. That is something that we all dealt with it. If there is a problem, we jump into the data center, we fix the role access in the policy.json, we bring it up, we are all happy. It would work as long as the data centers are minimal or less, right? Definitely, it's not a scalable solution. And the second problem is you would have to wait for an entire release timeline, right? Nobody would let you to go and touch all these files in a traditional way. So how do we automate it? That's the key. So the So we came up with two options, or two strategies. One, we call it as the rapid RBAC strategy. The other one is the dynamic RBAC strategy. If you talk about our, rapid RBAC, what we do is we predefine the granular roles. Very simple, right? If you take any service, what we do, there's actually 4 types of operations, a CRUD operation, right? We do a create, read, update, and delete. You could as well create these bunch of predefined granular roles per service. You can then add these roles to the groups, and you can basically add a user to the group. As simple as that. And in fact, my team is going to talk in more detail on that, how they do it with a simple use case. And in dynamic, what we really do is it lets you to define some ad hoc, even fine-grained roles. For example, I just want an access to this specific API. Then actually you need to go and touch the policy.json file in the backend. Of course, we would love to do it if there is an API-driven policy framework, but unfortunately, it's not that mature. So at this point, we are even ready to go and change the policy.json in the backend. Now, in order to do that, you can define these policies centrally in a central location, and there should be a distribution manager that actually distributes these policies consistently across different data centers. That's where actually what we did is created this framework within AT&T. We call this as the OpenStack Resource Manager. I just wanted to share the architecture. It's not open sourced yet. We are trying to investigate other OpenStack strategies and probably will make a decision. But at this point, it's a very simple and scalable architecture, right? It has 3 core components. One is resource management services. If you wanted to define a resource, say it's a tenant or a user or a project, you wanted to define an image or you define a flavor, these are the key things that are prerequisites even before you spin up any workloads. So you would go back to the service and define it. The second part is the distribution piece, right? We are all more into what is called the data model or declarative type of definition. That's exactly the policy that we are actually following here. We would define this in a template. You know what? What is the template we use? Heat. You can define all these infrastructure resources via heat, but we are not even limited by that. You can even go with the different type of templates, like you can go for a Helm chart. You can go for an Ansible pull script. Feel free to do it. It's just a type category that you can differentiate what type of document that is. Once you define the document, you store it in the document repository, and you simply click a trigger for all these data centers. What it is going to do, it's going to pull the resource template, and it's going to create those resources in the respective data centers. And then we also invented like a region catalog service, just like a Keystone catalog. If you wanted to know what the region capability is, you should be able to do that. So with this, I think I'm going to hand over to my colleagues here who's going to walk over an end-to-end use case leveraging this ORM technology, and we'll also show you a demo on how to do that.
Okay. Thank you, Ganesh. Good afternoon, and thank you all for sticking around until the end of the summit to attend this session. So, as Ganesh mentioned, RBAC has been a growing pain since the beginning of OpenStack. And initially, we had a member and an admin in RBAC. And because of the massive amounts of deployment and the dozens and hundreds and potentially thousands of cloud, it has become a pain for large OpenStack deployments and large organizations to manage RBAC across multiple OpenStack clusters. So I'm going to talk a little bit about the rapid RBAC strategy that we defined earlier. And it leverages roles, groups, and users. And this works for Keystone v3. So groups, as you know, is probably some of you might know, is a construct in Keystone v3, just like domains. And for the sake of the example over here, I'm going to assume we have one domain. We can also use domains in order to divide or dissect the access across the organization. But in this specific use case, I'm assuming we have one default domain so we can explain what the strategy is about. So the idea is to define a set of granular roles, as you see here on the far right. So these granular roles will be mapped to one or multiple groups. And the groups themselves represent the different parts of the organization. So The groups can be different parts of an ops organization, can be tenant VNFs, can be capacity planners, and so on. So each group will have a specific set of roles, and then the users from the organization will be mapped to one or multiple groups. So the relationship between roles and groups is a many-to-many relationship, and users to groups will also be a many-to-many relationship. And one of the important principles that I'm trying to adhere to is the least privilege principle. I do want to give my users least privilege to some extent, right? As much as I can. Because let's say I have, and I'll go over the use case in a little bit, but I don't want to give everyone admin access. I mean, that's the idea, and that's, I think, the pain point that everyone is struggling with. For example, and I said users across the organization, that can also be machines, right? So it could be a human, it could be a machine, it could be an application. For example, if I have an ONAP application that is trying to manage a part of the cloud, I want to make sure that application has least privilege access. So for example, here's a use case. I would like my capacity planning team within my organization to manage host aggregates. So I want them to be able to create, update, delete, and read host aggregates in one or multiple OpenStack regions. So if I give them admin roles, the problem is that they will have a lot more privileges than they're supposed to have. And they would be able to potentially maybe mess up somebody else's Cinder volume, or mess up delete a tenant image, or something like that. And so I really want to avoid this. So what can I do as part of this rapid RBAC strategy? The idea, like we mentioned earlier, was to define these granular roles. And I want to do that per OpenStack service. And so once I have these granular roles defined in my code, in my OpenStack code base, I will follow these 3 simple steps. Step number 1 is to create a group, or reuse an existing group if I have one. And then step number 2, I want to add the granular roles that I have already into my group. And then step number 3 is I want to assign a user to a group. So in more detail, these granular roles, like I said, are predefined in my code for multiple projects. And we have selected a certain level of granularity. Now you can go as much as you like into defining a granular role per API action, but we have picked a certain level of granularity that works for our use case. And in this case, I have for Nova, for example, I have a tenant Nova create, update, read, and delete, and I have an admin Nova create, update, read, and delete. And I did the same thing for Cinder, and I similarly defined roles for the other OpenStack services. So this is done in my code base. This is done before I execute steps 1, 2, and 3. And basically, the reason is I want to assume that I have the same code base across multiple OpenStack regions before I actually do any manipulations. So this is the rapid. The rapid part is really the 3 steps that the folks at managing the cloud are able to execute without touching the code base. So let's go back. Step number 1 is I use a simple Keystone v3 API to create a group. So I create my capacity planning group. Then in step number 2, I add the appropriate roles to the capacity planning group. And in this case, it's the Nova create, update, read, and delete. So this way, because host aggregates is a mechanism in Nova to dissect the hardware landscape across an OpenStack cluster. So I have multiple hardware. I want to be able to segregate that using host aggregates. And we have noticed that in a lot of cases, capacity planners have to modify this on a regular basis, but we don't want them to do more than that. So we're trying to limit what they're able to do. So we execute step number 2, and then I go and pick my users that are part of the organization in order to add these users to the capacity planning group that I just created, and then I'm done. So now my users within the organization have these privileges that they're able to basically manage host aggregates across one or more OpenStack regions. So again, just to recap a little bit, what we're doing here is I'm creating groups that really represent what the organization is like, and I'm giving these groups these specific roles or privileges that they need, and I'm placing users within these groups as needed. One thing I want to note here is in the telco use case, we don't really use Horizon much. So this solution is catered towards all the API calls. And like I said earlier, there's humans and machines that are accessing all these OpenStack services. And essentially, we are able to provide the granularity that these humans or machines need. And for Horizon access, if it's needed for your use case, there are the default roles that we have in OpenStack typically, like member or admin. And we also have some platform-wide roles where you're able to view more than a typical member can view and less than, for example, what an admin role can see. So we do have platform-wide roles that work across multiple OpenStack services that we're able to leverage for Horizon, for example. And I want to mention that I've been following the community and what is being done today in terms of default roles, in terms of other projects that are out there. And we really would like to be aligned with the community. And this solution or this strategy over here works for us until we define the ideal way for us to go about simplifying and standardizing RBAC across, like I said, hundreds or thousands of OpenStack regions. So I did talk about the rapid RBAC strategy. I want to mention a little bit about dynamic RBAC. So dynamic RBAC is the solution that we're defining in the case where the granular roles that I have defined in my rapid RBAC do not really work for me well enough. And I do want more granularity, and I do want to be able to, for example, create a new granular role dynamically in one or more OpenStack regions. And the way I do that, I leverage the ORM framework in order to update my policy.json with these granular roles across the OpenStack regions where I need to do that. And this is the framework that I can leverage in order to do that. And Sharat now is going to talk about the current community projects and is going to show us a demo of how we leverage the rapid RBAC strategy as well as the dynamic RBAC strategy.
All right, thank you. Thanks, Ronnie. So let's look at some of the community projects that we can leverage to enable us to do this both rapid and dynamic RBAC. We'll start with an existing project in OpenStack, which is Kingbird. Kingbird is a centralized resource orchestrator within OpenStack. It allows for resources to be orchestrated to multiple OpenStack regions, but it has a limitation that it requires a centralized keystone. As you heard before Ganesh say, the evolution of the cloud architecture has moved away from a centralized to more localized keystone. Hence, there is some limitations to this project. The other frameworks which are complementary to what we are proposing as part of the dynamic RBAC are Congress, which is policy as a service, whose whole purpose is to do policy enforcement. It does both a proactive policy enforcement as well as a reactive policy enforcement. As part of this policy enforcement, along with the rapid or dynamic RBAC, security policies can be enforced on the OpenStack instance. The third framework that I'm going to touch about is the Open Policy Agent. This is a lightweight policy engine that actually shifts the policy decision away from the services to an OPA agent, which is running outside. So the policy decision point has moved. This also allows for declarative policies. So going with the notion of declarative cloud deployment, wherein you want to say what you want the cloud to be, this aligns with that vision and that viewpoint. One of the most important factors or attributes of OPA that we like was the fact that OPA could be applied to multiple layers, not just the OpenStack layer, but as well as the other layers within the cloud stack, such as the Kubernetes layer or the Ceph layer, in order to provide the unified RBAC solution that Ganesh was talking about. In the next slide, I'm going to talk a little bit about how we envision the centralized policy management to be. In our case, the centralized policy management for all OpenStack services should have the ability to define the standard roles as well as granular roles, and these roles would be applied to all the different OpenStack services. We would also like to have support for obviously separating out scopes either at project level or at system level, and then we need to test this roles and RBAC via Petrol. We can obviously leverage OPA along with the Oslo policy here for actually doing the centralized policy management, and use the ORM architecture that Ganesh explained before for the distribution of the various policy files. Now coming to the interesting part, which is the demo. So let me just set it up a bit. So what we have is a smaller version of ORM running in a central location, and we have two different OpenStack instances running in two separate regions. So we will try to do both the rapid RBAC as well as the dynamic RBAC for these two instances. So the use case for the rapid RBAC is, as Ronnie was explaining, wherein we get a capacity planning group, add a user to that group, and then try and see that the capacity planner has the ability to create host aggregates. In terms of dynamic RBAC, we use the same user. Now the user has the ability to create, but he may want also the ability to delete the host aggregates only and not anything else. So we will look at how we can edit the policy JSON dynamically to add this role as well to this user. Okay, so we'll start off the ORM. As you can see, once the ORM kicks, it loads two instances that it has seen as part of the OpenStack instances. Now we'll start with first creating a group, a capacity planning group. Once we create the group, we add a user, Tim, the planner, who wants to go ahead and actually assign or create or list host aggregates. As you can see, once we create the user and the group, we'll go ahead and use ORM to do the same on both the instances of the OpenStack instances that are running. Once we do this, when the team logs into the site, sources himself, right, to see if he can run the CLI commands, he'll not be able to do the aggregate list because this group has not yet been assigned that granular role. So the granular role to list aggregates is not yet assigned to the user, so the policy will fail. So now let's go back, assign that granular role, which is tenant aggregate admin, to this group, the CPE group. So all users within this capacity planning group can actually make use of this role. So once the role is added to the CPE group, we'll see that the user, the planner, is able to now list the aggregates, right? So we see that two aggregates are there, AG1, AG2, and he's able to list. But let's assume that AG2 is not a valid host aggregate and he wants to delete. And when he tries to delete the aggregate, because the granular role is not assigned, he will actually fail. This is where dynamic RBAC comes into play, wherein now we can assign this granular role, which is the tenant aggregate admin, to the group, CPE group, so that they can delete the aggregate. How the dynamic RBAC would work is it would take in the API that it would want the role to be assigned to. In this case, it is the delete API for the OS aggregate within the policy JSON. Then we would take in the role, which is the tenant aggregate admin. Once the data is input, we would use the Helm to actually do a rolling upgrade of the policy JSON. So initially, you can see that the current OpenStack instance does not have the tenant aggregate admin role assigned to the delete. So Helm will now go ahead, the Helm chart with the updated policy JSON will now create a rolling upgrade. It will first change the policy JSON, and we should shortly see the policy JSON file updated with the appropriate role. And as you can see here, the delete is now, API now has the role tenant aggregate admin. So now Helm was doing a rolling upgrade, not only of the first instance, but of all the instances that are there that ORM has recognized. And then it will do a rolling upgrade to prevent any impact to the workloads that are running on that site or on that location. Once the rolling upgrade is completed on all the instances, now the user has consistently this role assigned to all the different groups, or to this group in all different instances. And he is now able to go ahead and delete the aggregate that he previously created in error, which was the test ag2. So now that when the user tries to delete, because the role has been assigned, he is successful. And there you go, no error messages. Let's list. And as you can see, once we list, we can see that the aggregate has been deleted. Now, that is the demo for the dynamic RBAC. The final slide is actually a call out to the community as to what we want to see. We want to bring RBAC to the forefront. Look at enhancements to Kingbird, not to have maybe like a dependency on a centralized keystone, and look at what the telco cloud deployments or edge locations would need with the localized keystone. We would also look for a centralized policy management that we just discussed before, as well as the ability for a policy management API to make these policy changes instead of going and making a manual change or an automated change in the file. And I know Neutron has made that effort, starting with the RBAC for Neutron. We need to enhance that and bring it up to other services. That's our session. We'll now open for question and answers.
Thank you.
Thank you.
So question and thoughts. First, something I just haven't kept up with. If I were to like cat the host aggregate admin file you had there, that particular policy, right? How granular, like how deeply, if we think about everything that Nova represents as a big hierarchy, right? The big YAML or JSON file. How specific, how far down the tree branches can you get when you're referencing attributes or components within Nova? Like, can you make that a super explicit string? Like, is host aggregate a named element, or is it a higher level privilege that you're adding or deleting there?
I can answer that. Okay. So there are ways to define granularity, like I mentioned earlier. If you look at what the community today is doing, there's a blueprint in order to define sets of roles across multiple OpenStack services, and that's, for example, there's a auditor role, and there's a member role, and then there's an admin role, and a member is a superset of an auditor, and an admin is a superset of a member, right? And so there's a certain hierarchy in what each role can do, and the higher hierarchy can do whatever the lower hierarchy can do, right? So that's one way to do it. In this case, we segregate a little bit more, so we don't really define a certain hierarchy in these granular roles. We more segregate them into different subsets. And so you can go as granular as you like, and you go as, but In our case, for the rapid RBAC strategy, so if I cat, let's say, a tenant Nova read, there's a lot of the read actions that are in the API verbs or the API actions in that policy.json that I would roll up under that role. And so I do similarly for other API actions as well.
So slice it the other direction, right? That's hierarchy and organizationally. Slice it from the resources. I'm asking because we solved this exact problem in Open Daylight in a weird, lazy, and convenient way. So if you were to slice that same role by looking at the way you create a heat template for like things, right? For VMs and ports and things like that, instances and ports. If you were to slice a port down to like the most specific attribute that you can name with a heat template, can you call that out in a policy yet today? Or is that the work you said that they're working on, making the individual attributes of an element within a port identifiable via policy? Because if you can do that, you can have really simple, I mean, it looks like a URI, basically a hierarchy with regular expression type wildcards at each level, such that now you have the hierarchy of roles you said, where this grouping now has permission to think of it like /neutron /OVS /port
right.
some setting. And that's exactly how we did it. We made it look like URIs with wildcards at each piece of the
Each
URI.
level.
So interesting.
And then you could do that within Keystone and not try to bring in maybe a project that has a different topology or yet another new agent, yet another new service on my controller.
Yeah, I think you're going one level ahead of
So,
super fine-grained roles, right?
Yeah.
So I think it's certainly doable. I definitely wanted to sync up with you on.
Again, we had the same problem. It wasn't granular enough until we just treated every structure like a hierarchy and just.
I think we wanted to solve the problem at least like 95% with the rapid RBAC because we kind of understand our ecosystem and the different users. But there are always the corner use cases, right? And that's why we have the dynamic.
I think everything that you guys did is awesome. The way that you're distributing these things, the way that you're like, hey, default to heat, all of that is great. If Keystone had that notion of whatever the resource is, whatever the subservice is, just tag it all the way to the bottom of the tree. So I think this smells like a Keystone project, but easy for me to say coming from another project.
Yeah.
Thank you.
Thanks, guys. Great work as always.
Thank you.
Thank you.
Hi, I have two questions. First is, what if I want in one region that the user can delete the host aggregate? In the second, I don't want him to delete the host aggregate. How can you achieve that?
Yeah, certainly that is doable. I mean, as part of the ORM framework, the templates that is defined, you could actually define to a specific OpenStack regions. So region 1, you can define a different policy like you want, and for region 2, you can alter that.
Okay, thank you. Second is, you said that actually currently it's not working with Horizon. Is that true? So it must be done by the API?
No. What all we said was you can use Horizon, but for this specific use case, we didn't really solve for Horizon. So users that need to access Horizon do not need to use these granular roles. They will have, if a user needs to access Horizon, they will have other roles like member or admin or platform-wide roles so that we've defined, that we've called them different names, that they will be added to them in order to access Horizon. So they'll be able to access Horizon, no problem. But if they only have these granular roles, that's not what we're solving for.
I see. Thank you.
Could you describe in a little more detail what kind of enhancements you're looking to see in Neutron as far as enhancing the RBAC or support for RBAC?
No, I think generically we wanted every OpenStack services to define RBAC via APIs. If you actually see Neutron, they just provide like a network visibility, I believe.
The sharing of networks today, right? And that may not necessarily be sufficient because as he was pointing out, you may want to go more granular. You may want to do more things. You may want only certain people to delete. You may want only certain people to create, right? So that granularity does not exist today. And they have made a start by now allowing sharing of the networks via API, but we want to enhance it to allow for more fine-grained roles via API. And that's
even when we actually did some SRIOB related work, we had to have kind of an admin privilege to kind of execute some of provider networks related to SRIOV. We certainly don't want to do that. We don't want to provide a super privileged user, the role, unless until it's absolutely required, right? So that's the whole problem that we wanted to solve. So yes, I think to your question, we would like to see each of the service themselves exposing more APIs, or like we shared the OPA, right? Open Policy Agent, where we could centralize it and easily do it in one place.
Okay, yeah, I think they're kind of two separate items. The policy, I agree that needs to be exposed in an API and make it easy for people to make modifications to that. But the Neutron RBAC APIs, from my understanding, are more geared towards just granting access to a network so that users can attach them, same as you would grant, say, a project access to a flavor, or in Nova or Glance share a particular set of images with set of projects. So it seems to be who has access to use this resources versus who has access to perform operations against that resource, like CRUD operation.
Right. You're right. It's very minimalistic in our view. I think certainly we could extend is what we are saying.
Okay, thank you.
Thanks.
It was a nice talk, guys. I had a couple of questions. Are you extending this to the airship environment to support roles in shipyard and things like that?
So it's a very good question. So in fact, if you have actually seen the airship, they are also leveraging Keystone as the RBAC or identity management. So yeah, certainly we could, since the backend is the same, we could leverage something like this to distribute the policies consistently for all this under-cloud orchestration, which is what Airship is doing.
My second question was, how do you, so this is roles. How do you synchronize credentials or passwords or keys or things like that? Does this have any role in that, or is there another mechanism that you use for that?
So, that's basically in the LDAP, right? Which Keystone uses. So we use a centralized LDAP in order to store user credentials, and then the Keystone tokens is a separate. I think a separate problem to solve.
These are corporate users.
Yeah, sorry, ORM does not solve that problem of how to synchronize between multiple LDAP backends or where your keys are stored. It does not.
The authentication is still LDAP. What we really cover is the RBAC part. Thanks.
Right.
As I understand you correctly, you are always rolling a new policy files on the cluster, yeah?
Not necessarily.
We are updating the existing policy files.
Okay, are you aware, or have you testing this HTTP hooks in policy engine?
The what hooks, sorry?
The
HTTP hooks.
Yeah.
To have just only one version of policy file and make decisions outside of OpenStack.
That's exactly what we think that leveraging OPA kind of a framework would help, so that you don't want to rely upon all these policy JSON in the backend, right?
Yeah, it would.
So right now, this is what we got, and we try to see how we can fit a solution that would work right now. But that's where I think we would leverage, all these frameworks that are already available.
That's why we want to take the policy decision away from each service and make it more centralized, so we can do things of interest there and not make a lot of changes all the time and have a simple.
I think it would be easier.
Yeah, that's right.
Agreed.
Thank you.
Thanks. All right.
All right. Thank you. Thank you all for the time.
Thank you.